Properties of logarithms. Before we dive into the properties of logarithms, let's start by answering the question, what is a logarithm? Consider the exponential equation y equals b to the x, where b is some number greater than 0. We often call b the base of the exponential equation. My claim is that the following equation, x equals log base b of y, is the exact same thing as the exponential equation y equals b to the x. Now, why is that a true statement? Simply because we say so. That is, a logarithm is just a different way of writing an exponential equation. Now, in an earlier video, we talked about the logarithm being the inverse of the exponential. For example, if I had y equals 2 to the x, and then we had the equation y equals log base 2 of x, these were inverses of each other. Notice, though, that these expressions up top are different than these expressions or these equations down below. So the second one is inverses, but this first one, that is this first set of equations, is just a different way of writing the exponential. Now, one thing that I really want you to take note of here, because this will help us understand properties if you take a little time to think about it, is that this x is the same as this x. What are the implications? The logarithm is the exponent in the exponential equation, right? We have y equals b to the x. The same x is down here, but we call that log base b of y. So the logarithm is the exponent of the exponential equation. How does that help us out? Well, let's take a look at some of the properties here, and I'll rewrite what we have just so we can kind of follow along. Y equals b to the x, and x equals log base b of y are equivalent expressions. So first property, kind of a really basic property. And in the left column, I'm going to put down our exponents. That is the properties of exponents. And in the right column, I'm going to put down properties of logarithms that correspond. So the first really basic one is that anything to the 0 power is 1. So if I were to write that in logarithmic form, I could say the log base b of y, that is, the log base b of 1 equals 0. So anything to the 0 power is 1, and the log of 1 any base is 0. Now let's take a look at some of the more complicated properties. We know that when we multiply two things with the same base, like x to the m times x to the n, we can add the exponents. The property of logarithms here, log base b, we have the same base, of any two things that are multiplied says that we can add the logarithms. Let me make that a little bit clearer. Hopefully, that's the m times n. So here, when we multiply two things with the same base, we add the exponents. Over here, when we multiply two things with the same base, we add the logarithms, because the logarithm is the exponent. How about the next property we talked about? What if we divide two things with the same base? Well, then we can subtract the exponents. What if we, over here with logarithms, divide two things with the same base b? Then what do we do with our logarithms? Well, we subtract them. All right, dividing two things with the same base, we subtract exponents. Dividing two things with the same base, we subtract logarithms, because the logarithm is the exponent. Our final major property, what if we have a power raised to a power? In this case, we multiply the powers, or multiply the exponents. So what if we have a logarithm where something is raised to a power? We can bring that p, the power, down in front and multiply it, like this. The log base b of m to the p is p times log base b of m. Once again, if we raise an exponent to a power, we multiply the exponent of the power. If we raise something to a power inside a logarithm, we multiply the power times the logarithm, because the logarithm is the exponent. In the next video, we're going to use the property of logarithms to solve problems or simplify things to help us understand these properties a little bit better.